Welcome. This lecture is called Basic Network Concepts. We are going to introduce some definitions from graph theory, in particular the definitions that define a graph or a network. In general, a network is going to be a set of um, two main things. They are called vertices. Each vertex is represented here as a circle, and also there may be some vertices that have a connection between them, which in this graphical representation appears as a line. That connection between two vertices is defined as an edge. So the set of vertices and edges defines what we consider a graph or a network. And in this discussion, I'm using the terms graph and network interchangeably. So we would also refer to a vertex as a site, a node, or an actor. And this is the fundamental unit of a graph or a network. And the line connecting um, two vertices is considered an edge. It's also referred to as bond, link, or tie. And the set of vertices and edges is what is defined as a network or a graph. Now, given that each vertex may have a number of edges, edges coming in or edges going out, this number of edges is called the degree of a vertex, is the number of connections. And the definition of a graph or a network is something that involves space, just like in this picture here, just in this illustration, there is a sense of how in the vertices represent locations, and then ones that are edges between vertices, then there are means of reaching one location from another location. And so there is a sense of space, and therefore in that space there will be a sense of a path given by a sequence of vertices. A path is any sequence of vertices such that every consecutive pair of vertices in the sequence is connected by an edge in the graph or network. And so that idea of a path will connect or will be related to distance in the graph or network. Okay, and so this brings now my next illustration that has to do with one of the very prolific mathematicians of all. This mathematician, his last name was Erdős. Here is a representation of the following. Turns out you could refer to a graph such that every vertex in this graph will represent a mathematician, and two mathematicians are going to said to be um, joined by an edge if they co-author a publication. If they publish an article or a book where they are both co-authors, then that will define an edge between the two of them. So this was a hand drawing by Ron Graham, 1979, where he represents the edges here encircled by each edge has the last name of a mathematician, and then there are lines according to this rule of drawing a line, and then at the center of the universe in the mathematical world of publications appears Paul Erdős. Paul Erdős was a highly prolific mathematician, visited many universities, and would have extended visits and would solve conjectures or open problems during his 2 or 3 week visits, and therefore in a given month, in a given year, there will be a lot of these collaborations co-authoring with Erdős. Okay, so let me motivate this with a very concrete um, example of a database for mathematical publications. Very well. So here we have the main website, the homepage of the library at ETSU. This library is the Charles Sherrod Library. So it would be best if you visit this URL. And once you are in the homepage of the library, select this drop down menu research, and under research, we're going to visit this tab called databases. Okay, so main page, home page of the library, and we go under research, and from research, we select these databases link. And so this leads to this part that says alphabetical by name. This is sorting the databases, and we're going to go to the letter M as in mathematics. I'm going to choose M. And then listed on the top here under M, it appears this database called MathSciNet, which is what we choose next. And then MathSciNet looks in this form. It turns out this database stores information on publications, and that is articles and books. So each record that's stored in this database is going to contain several entries. Each record is going to contain the names of the author, the title of the publication, the journal in which it appeared, and there are some entries that are for codes, for specific codes, sometimes even the name of the person that reviewed the article, and there is this classification anywhere is basically when we're not sure about, we only have partial information, and then we can do a search with keywords or key phrases, something of that sort. So we're gonna go to the first term, select author, and I'm gonna type there my last name. Okay, and then we're gonna do a search with my last name. Then you will see the type of information that's displayed. So the database has identified a number of records in which my last name appears in that field for author. Okay, so let's take a look at this second entry here on this list. There are two authors. I'm one of them, and then there's a title. This publication was called Prisoner's Dilemma on Social Networks Revisited. There is the name of the journal, there is the year of publication, number of pages, there is also some internal code. This database is maintained by the the American Mathematical Society, so the AMS has their own codes for archiving some of this information. Okay, so the idea is that once in MathSciNet, we're going to go to this top part of the web page, and we're going to choose this link that says free tools. Okay, this link links this other page. There is a tab here that says search MSC, another tab with collaboration distance, current journals, current publications. We're going to go with the second tab that says collaboration distance. You can type there my name again, and we're going to choose Erdos, okay? And then we're going to hit search. And by doing so, this comes back with a number and also here a sequence. It says that Syntron Areas published an article with Gadboli. Gadboli published an article to Janssen, and Janssen published an article with Erdos. Okay, and because there are three sequences of collaborations here, then there is a number three. This is the so-called Erdos number. So another way of thinking about this is that the author Syntron Arias, that's myself, is within 3 degrees of separation from Paul Erdos. So basically, um, degrees of separation and Erdos number, they are about the same kind of thing. Okay, and so mathematicians keep track of this Erdos number as because they are thinking on the collaboration network in the universe of publications of mathematical research. So we go back to this slide in which we're referring to the Erdos number, the definition of vertices, edges in this collaboration network, a path, as the number of edges required to travel from one vertex to another, and then so distance is going to be quantified by the shortest path length between one vertex and another, and so the Erdős number is quantifying that shortest path length between one collaborator and Paul Erdős, one mathematician and Paul Erdős, right? So this illustration here is precisely visualization of a collaboration graph in research, in mathematics research. This is a snapshot from a while back, and back then my Erdős number was 4, well, we just revisited an example by going to the homepage of MathSciNet and recomputed that number. This number is currently not 4, as you saw. But this, in a much broader sense, is addressed by a publication by Newman called "Who's the Best Connected Scientist?" And here you see an illustration with much better resolution of the same kind of thing. There is a scientist. This is no longer exclusive of the field of mathematics. I'll let you review that. You can download a free version of Who's the Best Connected Scientist from this URL in the archive. There is a scientist here at the very center of this universe of publications, and then there is a first layer of collaborations that forms very nice symmetric, right, circular shape, and then out of that first layer, there is a second layer of collaborators, right? So this is a very high resolution illustration. This is a low resolution illustration that was done by hand, but they are illustrating the same type of ideas.